Hello everyone and welcome back. Today we are going to solve this question. So we have to find the volume of the figure formed after rotating the graph of y is equal to 1 by 2x plus 1 about the x-axis. So y equal to 1 by 2x plus 1 has a graph something like this. It will touch the x-axis at infinity. So if we rotate it about the x-axis, I will draw in blue what we are going to get. I'm going to draw this in blue. This will go exactly as it is, and we'll get a similar thing, the same thing, even under. So, and this is a 3D shape if you can visualize it. These are all circles, circular discs. This is a 3D shape, and we are asked to find this volume as it's going to infinity, from 0 to infinity. So let us see how we approach this. So we are going to require integration for this. So first, let us try to see let us see the approach. So as we know, we can divide this shape into multiple discs of thickness dr, or let us take it as dx. So but what is the radius going to be? It is varying for each disc. So thus the radius is basically going to be the y value of the function at that point. So our radius is going to be 1 by 2x plus 1 at x. So let us write radius as a function of distance, as a function of x. Radius as a function of x is 1 by 2x plus 1. So this is a cylinder, a disk is a cylinder, so the volume of this is going to be pi r square h. What is h in this case? H is dx, and radius is 1 by 2x plus 1. So we are going to get a small volume of a small disk is pi and times r square, that is 1 by 2x plus 1 whole square, into h, that is dx. So we are left with this equation. So we get dv equal to pi dx by 2x plus 1 whole square. We have this equation. So if we integrate this on both sides from 0 to a, 0 to v, we'll get the total volume of the disk. So let us do it. So integral of dv is just v, from 0 to v, it's just v. Because we are substituting appropriate limits here, we don't need to worry about any integration constant. So we are left with v equal to pi, I'm getting the constant out of integration, pi integral of dx by 2x plus 1 whole square from 0 to a. Let us use a substitution for this. Let us take 2x plus 1 as t. So differentiate this on both sides, we get 2 dx is equal to dt. So we get dx is equal to dt by 2. Now let us put the values into the integral. So we get v equal to pi integral dx is dt by 2, and 2x plus 1 is t, so 2x plus 1 whole square will be t square into 1 by t square. So let me get the 2 out of the integration. So we have, let me write it here, v is equal to pi by 2 integral of dt by t square from 0 to a. We know that, let us use the power rule for this. We know that this is pi by 2 times minus 1 by t. Using the power rule of integral, we will get this from 0 to a. Now let us put the value of t back. So this is equal to here pi by 2 times minus 1 by 2x plus 1, and the limits are 0 to a. Now let us plug in the limits. I'll do it on the next page. Pi by 2 times minus 1 by 2x plus 1 from 0 to a. So this is going to be pi by 2 times minus 1 by 2a plus 1 and if we put in 0 into this, we are going to be left with -1. So this minus of -1 by, I'll write it down, 2 times 0 plus 1. So this will be pi by 2 times 1 minus 1 by 2a plus 1. So just taking the LCM and doing some basic simplification, we have pi by 2 times 2a plus 1 minus 1 by 2a plus 1, which is 2 times 2a by 2a plus 1. So we have it, our final volume is pi by 2 times 2a by 2a plus 1. This is not the question yet. What were we asked? We are asked to find the limiting volume as a tends to infinity. So let us do that also. So we have this. So let us apply limit as a tends to infinity of pi by 2 times 2a by 2a plus 1. We have this. So this function, let us take a common, is pi by 2 times a into 2 by a times 2 plus 1 by a. So as a tends to infinity, this term right here is going to be 1 by infinity, which is 0. The limit is going to be 0, so we can ignore this term. So and the 2 and 2 will get cancelled. This will be 0 anyway. A gets cancelled. So the limiting volume, limit as I tends to infinity of volume, is pi by 2. So and we are done. So the answer is pi by 2. Volume is equal to pi by 2 units